Modern physics has shifted its fundamental perspective. Matter is no longer viewed as a static thing, but as an active, ongoing process. We define physical substance as the geometric result of resonant interference patterns. These patterns become trapped and stabilized within the fabric of three-dimensional space. In this framework, solid matter is simply the manifestation of wave energy settling into specific, stable structural configurations. A standing wave foundation is formed when spherical inward-flowing and outward-flowing waves intersect. At specific intervals, these waves interfere with one another. This intersection creates nodes, which are points of zero amplitude. These nodes act as an architectural scaffold, trapping energy to manifest what we perceive as matter. The resulting geometry stabilizes the wave, effectively holding the frequency steady in space. Nodes are not empty voids. In our standing wave model, nodes are stationary points where the wave interference cancels to zero amplitude. These specific nodes serve as the architectural scaffolding for the physical universe. This is where fundamental properties like mass, electric charge, and spin manifest as localized energy configurations. By defining the geometry of interference, these nodes dictate the precise locations where a particle is allowed to exist, turning the abstract wave field into the solid reality we observe. Solid matter exists because energy is forced into specific quantized configurations. Imagine energy as a fluid wave flowing through space without restriction. However, when these waves encounter the boundary conditions of three-dimensional space, they are restricted. If a wave's frequency matches these boundaries, it stops moving freely. It settles into a repeating resonant pattern known as a standing wave. This is the essence of quantization. Energy is not continuous. It is forced into stable, trapped geometries. These discrete states are what we perceive as the building blocks of matter. In the wave structure of matter, entanglement is not a mysterious action at a distance. Instead, it is the result of shared geometric architecture. Every particle is an extension of a spherical wave field. When these fields interact, their wave fronts merge, even across vast spatial intervals. The particles are not separate entities. They are nodes in a single, unified wave field, explaining why measuring one instantly correlates to the other. By viewing matter as standing waves, non-locality becomes a geometric necessity rather than a paradox. By mid-2026, scientific progress has reached a milestone in wave control. Researchers have successfully harnessed phonon-polariton waves within synthetic lattices. By manipulating these waves at the nanoscale, scientists create precise interference patterns. These patterns mimic the mass and energy distribution of subatomic particles. This technique provides the first definitive evidence that we can engineer matter by stabilizing specific wave boundary conditions at the nanoscale. This breakthrough marks a shift toward resonant engineering, turning theoretical wave structures into observable reality. The Global Resonance Consortium has mapped subatomic particle traits, such as flavor and spin, onto spherical harmonics. These aren't just probabilities. They are precise geometric signatures. By viewing these particles as specific frequencies of a standing wave field, we can explain their stable properties through mathematical harmonics. These particles manifest as rigid geometric configurations. The frequency dictates the shape, creating the stable scaffolding we observe as the standard model. In this framework, flavor and spin are simply the characteristic harmonics of the universe's foundational wave architecture. Quantum hydrodynamics offers a physical, visual proof that matter follows geometric paths. By vibrating a fluid surface, researchers create pilot waves that guide a droplet's trajectory. In this experiment, the droplet does not wander randomly. It is surfing the waves it creates itself, proving that trajectories are determined by wave field geometry, not pure probability. This evidence challenges the standard probabilistic view of quantum mechanics, suggesting that what we see as randomness is actually the result of complex, yet deterministic, wave interactions. Chladni plates demonstrate resonant interference. When a flat plate vibrates, sand migrates away from areas of maximum motion and settles along stationary nodal lines. Atomic orbitals mirror this behavior. Electrons do not circle the nucleus like planets. they settle into resonant nodal boundaries dictated by quantum constraints. Just as sand defines the vibration mode of a plate, these nodal boundaries define the energy level and probability distribution of an electron shell. Light typically propagates as an unbounded wave field. To control it, we look to photonic crystals. Photonic crystals are engineered materials with a periodic nanostructure. They create a band gap that prohibits specific light frequencies from passing through. By trapping the wave within these boundary conditions, we effectively freeze light into rigid, geometric structures. This is a foundational step towards solid-state photonics. By manipulating these nodes, we demonstrate that matter and light are just different manifestations of the same underlying wave geometry. Historically, physics relied on the Copenhagen interpretation, which treated the state of matter as a probability cloud, inherently uncertain and non-deterministic. The field is now pivoting toward deterministic wave mechanics. By employing category theory, physicists map the relationships and transformations between wave states as formal morphisms. This evolution replaces uncertainty with structural logic, allowing us to describe complex wave interactions with mathematical certainty. We are entering a new scientific paradigm. Instead of asking what matter is made of, we ask which frequency is being held steady. Stability is simply a function of sustained resonance. A frequency, when held, creates a stable node in space. When these frequencies lock into place, energy transforms into what we perceive as solid matter. Matter is not a thing. It is a process, a frequency being held steady by the architecture of space. The paradigm shift toward wave structure of matter is driven by empirical data. Recent high-energy collision analyses provide compelling statistical confirmation. Standard particle-only models account for decay patterns with approximately 60% accuracy. However, models based on harmonic breakdown of standing wave systems align with observed data at an 82% rate. This significant statistical gap underscores the precision of wave mechanical predictions. What we observe in collision debris are not mere point particle remnants, but the resonant harmonic breakpoints of stabilized geometry. With an 82% correlation, these wave-based architectures outperform classical theories, marking a transition from probability-based mechanics to deterministic wave field analysis. Solid matter is not a collection of hard, impenetrable marbles. It is an electromagnetic interaction. When two wave-based structures approach, their fields overlap. We perceive this resistance as solidity. Our senses interpret the repulsion between our own wave-based atoms and external objects as a solid surface. Educational curricula are evolving, moving away from the outdated Bohr planetary model of the atom, which incorrectly depicts electrons as particles orbiting on fixed paths. We are now adopting the wave interference model. By visualizing the electron as a wave, we can finally explain why it occupies specific volumes of space, known as orbitals. These volumes are not arbitrary tracks. They are defined by the geometry of destructive and constructive interference, forming stable nodal boundaries. By teaching physics through the lens of wave mechanics, students can intuitively grasp that matter is defined by the boundary conditions of these vibrating standing wave fields. We are conditioned to ask, what is the particle? But this misses the architectural truth of matter. The question should be, what boundary conditions force the wave to settle here? Consider space as a field. A free wave moves indefinitely, but apply a geometric constraint, a boundary, and the wave is forced to resonate. When boundaries are applied, the wave cannot dissipate. It becomes a standing wave, forced to settle into fixed nodal geometry. Mastering the quantum world requires understanding that solidity is merely the result of these boundary conditions holding frequency steady. We live in a field of vibrating geometry. Everything we perceive as solid matter is, at its most fundamental level, a temporary harmonic equilibrium held in place by the geometry of space-time itself. Solidity is an illusion created by the resistance of these standing waves. We are effectively navigating a vast, intricate lattice of vibrating geometric potentials. The ability to tune the frequency of matter creates a new era for materials science. We are moving from a world where we build things to a world where we tune them into existence. Traditional manufacturing involves physical assembly. Frequency tuning, however, involves manipulating the underlying standing wave architecture directly. By shifting the boundary conditions of the field, we force matter to settle into specific geometric stable states. We do not construct the lattice. The resonance defines the lattice. This marks the transition to resonant engineering, where materials are simply manifestations of carefully curated harmonic states. The universe is not composed of isolated point particles, but of interconnected resonance. Matter is the echo of the vacuum itself, a stable interference pattern held by specific boundary conditions. By analyzing the geometric logic of these standing waves, we uncover the blueprint of existence. What we perceive as solid matter is merely the stabilization of energy into specific, rigid geometries. Understanding this harmonic foundation allows us to view the physical world not as a collection of static objects, but as a dynamic process of energy architecture. In the harmonic universe, to change the matter is to shift the frequency, unlocking the potential to engineer the very fabric of our reality.